Hi folks, how you doing today? Hope you're doing great. You're welcome once again to another new and fascinating mathematical video. Yeah. Unlike before, we shall not be considering solving past question in this particular video. Rather, we shall be dealing with concepts. That means we do it a detailed explanation on this particular video. All right. However, I want to still announce to you that if you're interested in a one-to-one tutorial, you can DM me, all right? We render such services. Then also click the provided link and it will take you to my Telegram group here where you can see other videos on other topics in mathematics. All right, let's quickly dive into the work for this particular video. Now, the topic here is the theory of logarithm. The theory of logarithm, and the subtopic we're considering is the general equivalent form of the general form m equal the x power of a, or you call it m equal the a to the power x. All right. And when we say equivalent form, we are talking about a different form that says the same thing as the previous. Now we have an expression for m equals to a to the power x. All right. Now there is a very useful form that is still saying the same thing as this. The name of the form is called a logarithm form. All right. So a logarithm statement is an equivalent statement to this power statement. Are you getting me? So we shall define it as follows. Now, one thing about equivalence are very important when it comes to mathematics, because the place where this expression will fail, we discover that the equivalent to it may not fail. So if you may not, it may be very difficult to prove a property by using a particular statement that is given. But the equivalence to that statement will enable you to prove it with ease instead of going through rigor. All right? That is one importance of equivalence. So if you are required to prove a certain property given a certain statement, now if that statement have an equivalent, if you can prove that the same result by the equivalence, you have equally proved the statement. That is one importance about using equivalence. When we're looking at logic, we shall talk more of equivalence so that you get the full grasp of it. All right, so let's quickly dive into the work and let's give our definition. So we'll be starting with definition. All right. Now we shall define briefly as m equal to the x power of a to be equivalent to, this is a symbol for equivalence. That is a double implication. All right. Some other textbooks call it if and only if. That is a necessary and sufficient condition. Then whenever we have this general expression, then we can write this x equal to the log to base a of m provided your a is positive, all right, and m is bigger than or equal to 1. Or even m can take other value. Let me put it, sorry, let me add this to it. This is not complete yet. A is positive and a is not equals to 1. We'll remove that case. Also, m must be positive. Can you see that? So we've defined, we've given a definition of the equivalent form, and these are the conditions that are necessary for writing this. Now, for you to write this as this without any barrier, these conditions must be satisfied. If you are considering this on the real line, these conditions should be satisfied. Then you are free of barriers. All right. So let's look at some laws, some properties of logarithms. All right. That will lead us to the properties of logarithm. So we shall be considering the properties of logarithm. First of all, what does this definition means? It means this expression here implies this expression, and in turn, this expression also implies this expression. All right, that is the meaning of the double arrow since a by implication symbol. That means whenever you have m equals to the x power of a, that implies x equals log to base a of m, provided the condition hold. And whenever we have x equals to log to base a of m, then we have m equals the x power of a. All right. So we want to look at properties. That is, the properties will be based on the operations, our usual operations of multiplication and division. All right. Now let's start with the first. Now let's suppose that we have n equals to the x power of a and n equals to the white's power of a, or you say a to the power y. All right, I think I will use the second pronunciation to bring home the understanding. Now, if we have this, then on multiplying, we have mn as the product, and that will be the x power of a multiplied by a to the power y. All right, and from indices operation, this is equals to writing x plus y. All right, so therefore we have that our product is equal to this. All right. Now, seeing this, from the definition we have given, the equivalent form of this should be written as this. All right. So we can have x plus y equals to the log to the base a of mn. All right. This should be the equivalent form of this expression over here. Can you see that? Now, we can still write this in a very useful form by noting that if m is equal to the x power of a, then the equivalent form of this is x equal to log to base a of m. All right. Also, if n is equals to the white's power or a to the power y, then the equivalent form of it is y equals to log to base a of n. All right. So we have this at hand. Hope you can see that. Now, the next thing we want to do, we come here. Let me call this star, for example. So from star, we have that mn is equals to, in place of x plus y, I'll put these expressions. Here are these expressions. Look at this and also look at this. All right. So we're having x plus y in star. Then our x is already equals to the log. Oh, sorry. We now have our x is log to the base a of m. All right. Then plus our y is log to the base a of n. All right. And that is equals to, on the right hand side, we have it as log to the base a of mn. Right. Now this, then we can rearrange it as log to the base a of mn to be equal to log to the base a of m plus log to the base a of n. And this is the first property of logarithm we've derived so far. Is the first property. All right. So let's call this one. Very, very important. Now the next we want to look at is the consequence of the definition. All right. That's the next we'll be considering. Number two, let's say if m is equals to the x power of a, as usual, then in the equivalent form of this is this log to base a of m. All right. Now, in the place of in this statement over here, in the place of x, I will put this log expression. That means that I will be having m to be equal to a. In place of this x over here, I will put the expression of the log. So we have log to the base a of m. So how do we interpret these statements? You see, we have a raised to a log. Now, whenever you see that a is raised to a log and the log has a base of a, then the result become m. That is, the number in this location is called the anti-log. All right. That is, all these are called antilog, 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 and so on like that. So if you have a base raised to a log, whose base is also that initial base, then the results of the expression become the antilog of the log. All right, so take note of that. So this is another law we've derived, very, very important. We shall be working with these laws. I should put them to mind. So let me box this we've derived right away. So I call this one 2. It's a useful law. All right. Example of this, an example of this is when we have 5 to the power of log to base 5 of 25. Now, observing this carefully, see that this 5 is raised to a log whose base is also 5. So therefore, the result of this entire expression become the antilog, which is 25. So in order to use this law number 2, you should observe these conditions. That is, a number raised to a log whose base is the number, then the result will become the antilog. It must be strictly observed for you to apply it. Otherwise, you will not get you'll be getting different and wrong results in calculation. All right. So let us go to another one. Very, very important. Number 3. Instead, let's divide these quantities m over n. Let's divide them. In that case, we shall be having the x power of a divided by the y power of a. And from our usual law of indices, this is equals to writing x minus y. All right. So that means that the quotient m over n equals to a to the power of x minus y. In the equivalent form, we shall have it as x equals to log to base a of m over n. In this case, the antilog is a quotient. All right, is a quotient. So we'll sorry, I not okay, there's minus y here, right? Okay. Now already we know what is x already over here. Let's come to this page. Look at this point. Can you see that? Can you see this? So these are s expression. Also, we also know for y. Where is it? Look at the one of y over here. All right. So putting this expression of log in the place of s and y, we have that for s, we have it as log to the base a of n, all right, minus. For y, we have it as log to the base a of n, and that is equals to the right hand side, which is log to the base a of m over n. All right, so rearranging this latter expression, we have the result as log to the base a of m over n equal to log to the base a of m minus log to the base a of n. All right. So this is another important result that should be taken into account. Very important. We shall be using all these laws to solve practical problems. All right. So take note of this. That is one law you should consider. Now the next one I want to look at is a very useful law that has wide application, even in calculus. Right. So let's look at that. That is number 4 now. Let's suppose m equals to the x power of a. All right. Now that means that the equivalent form of this is x equal to log to base a of m. All right. Okay. So we have this. Then let us raise this expression to the power p. So if we raise both sides of this expression to the power p, we shall have m to the power p equals to a to the power of x or to the power of p. All right. And from indices, we have this as m to the power p equal to a to the power of xp. Now also this can be written in equivalent form in various ways, but preferably we shall write it as sp equals to log to the base a of m to the power p. All right. Now we've already obtained an expression for x. Look at it over here. So in place of s, we put the log expression. So that means we're having, instead of s, we'll be having log to the base a of m multiplied by p, all right, equals to log to the base a of m to the power p. Now, rearranging this, we have log to the base a of m to the power p equals a log to the base a of m multiplied by p, which can be briefly written as p log to the base a of m. So what are we saying? We gather that log to the base a of m to the power p can be written as p log to the base a of m, and this is the result. All right, very easy. So I call this one 4. This result we are deriving should be taken into memory, because we're going to use them to solve some logarithm problems. All right. Um, so let's go over to deriving other useful results. Now let's suppose that we have this expression. Let's suppose we have the expression as number, that is we're now in number 5. Let's suppose we have m equal to e to the power x, all right, where a is positive. Now, if a is positive, it is true that a can be expressed as a power, all right, as a power of certain base. Let's call this b, for example. Since, okay, let me write this. Since a is positive, so there will exist, this symbol is for there exists some beta, such that there exists some beta, and not just beta, and b, which is bigger than 0, such that a is equals to b to the power beta. It is a well-known thing from analysis. All right, from analysis, specifically real analysis. If we are given a positive number, and there will exist other numbers such as beta and b that are bigger than 0. This beta you see here is not necessarily bigger than 0, but b must be bigger than 0, such that a equals to the beta power of b. All right, we have this is a true saying from the analysis, real analysis. Now, this, listen attentively. A equal to b to the power of beta. The equivalent form of this can be written as beta equals to log to the base b of a. All right. Also, m equals to a to the power x has an equivalent form of x equals to log to the base a of m. All right. Let's note that m, which is equals to a to the power s, cannot be written as instead of a, and I can put beta to the power b to the power of beta, because our a here is already b to the power beta. The all raised to power x. All right. We can see that. Then this implies we have b to the power of beta x, which on equivalent form reduces to beta x equal log to the base a, or log to the base, let's say log to the base b, rather, because the base is now expressed in b, log to the base b of m. All right, so we now have this expression at hand. Now listen, we have beta x, that is the product of beta and x. Don't forget that our beta now is this. So in the place of beta, let's put the expression for it. All right, and x, so we also have an expression for x, which is also this. All right, so on substituting these expressions, we have our result as, for beta, we have it as log to the base b of a, all right, multiplied. For x, our result is log to the base a of m, all right, and that is equals to log to the base b of m. Now let's isolate log to the base a of m and see a meaning out of this isolation. On isolating log to the base a of m, we have log to the base a of m to be equal to log to the base b of n divided by log to the base b of a. Now, what can we gather from this latter expression? What can we gather from it? Now, in some cases, the bases may not be desirable, so we can always convert the base to a desirable base. All right. Let's suppose that we have, now look at the order of things in which this particular result is written. Let's suppose we have log to the base 2 of 3. And this base 2 here is not amenable to our approach. So let us change this base to a base that will be suitable for any approach we intend taking. So let's suppose that the base that is suitable is let's say is alpha, for example. Now to change over to alpha, this should be written as log to the base alpha of 3 divided by log to the base alpha of 2. All right. So this is a law. Please don't confuse this law, this particular property, with the one of division. They are different things. Please observe them carefully. Look at this. This is not the same thing with what you are seeing here. Many students confuse them, but they are different. Take note of that. All right. Very, very important. All right. Now let us look at some special case. But before that, there's one law I want us to consider again. It will help us in simplification of logarithmic expression. When we are giving logarithmic expression, this one we want to look into now will help us to simplify it considerably. Let's consider it over here. It will be number 6. All right. Now let us suppose let m be equals to a to the power x and a be equals to c to the power of b. All right. Let's suppose this. That means in effect, we shall be having, that means if we should write this first one in its equivalent form, we shall have n equals to e to the power of s to be equivalent to s equals to log to the base a of m, on which if we substitute this expression, we shall have it as log to the base a to c to the power of b of m. Now our aim here is to look for a result of this. What does this mean? The meaning of this. All right. We want to look for a meaning of that. So how do we go about this? All right. Let me take more page so I will continue the work. Now please pay close attention as it is important. All right. And don't forget that when we have a equals to c to the power of b, this implies that we have b equals to log to the base c of a. All right. And also when we have m equals to a to the power x, this also implies that we have x equals to log to the base a of m. All right. Hope you observe these things. So in effect, we are trying to look for a result of this particular expression. So how do we go about it? How do we go about it? Now, on defining a equals to c to the power of b, it implies as usual that m is equals to that would be c to the power of b or to the power of x. All right. If you can remember that. So this is equals to writing c to the power of bx. Then that means we have m equals to c to the power of bx. All right. Then on equivalent form, we have it as bx equal to log to the base c of that is a log to the base c of bx. All right. So we have something of this nature. Then sorry, of not bx, of m. Sorry for writing bx. is an oversight of m, all right? Okay, now listen, pay attention. You see that my x is already obtained. What is the equivalent form of okay, this is it over here. Look at it. Can you see that? So in place of x, I'll put that expression. That means I'll be having I'll be having log, sorry, b multiplied by log, take this up a little, log to the base a of m. All right, and this can be written as b multiplied by log to the base. Now our a is already defined to be this. All right, so I can put c to the power of b, and that is equals to, or that is equals to this. All right, we can see that because this is a bx and this is my x already, so it's equals to log to the base c of m. So we can, please put m here, we can isolate. Let's make log to the base c of b of m the subjects. In this case, we now have our result as log to the base c of b of m to be equals to 1 over b log to the base c of m. All right. So this is a very useful result, which we can write as log to the base c of m to the power of 1 over b. From this law we derived in where is this again? Let's look for it. Yeah, from this number 4. From this, the reverse is possible. Please take note, the reverse of all we've considered, they are possible. So by the reverse of this, that is, whenever we have this expression here, we have this as a result. And whenever we have this as a result, we have this. Whenever we are given this, we have this as a result. All right, the reverse is possible. So when working with the laws, always think of the reverse. Very important. Now we have this. So we can gather that, all right, we can say, therefore, the log to the base c of b m has the meaning of log to the base c of m to the power of 1 over b. All right, so this is it. So in other words, to take this into account, very important, let me call this 6. In other words, if we have something of this log to the base 2 of 3 of 5, we can interpret it as log to the base 2 of 5 to the power of 1 over 3. That is the meaning. All right. So take note of this, and this can be further interpreted by law 4 as 1 over 3 log to the base 2 of 5. These two are the same thing. All right. So let's look at some special cases before we end this video. Special cases. Special cases. Now note that a is equals to a to the power 1. All right. And in equivalent form, we have this as 1 equals to log to the base a of a. So this is a very general rule. So that means, example, if we have log to the base 5 of 5, that will give us 1. All right. Log to the base 2 of 2, that will give us 1, and so on and so on. All right. Then let's look at another case again. If we have, listen, if we have 1 is equal to writing a to the power of 0, where a is not equal to 0 as in our definition. All right. So the equivalent form of this is writing 0 equals to log to this a 1. What is it saying? It's telling us that the log to a positive base of 1 is always 0. It's always 0. So that means in effect, log to the base 2 of 1 is 0, and that is also equal to log to the base 3 of 1, and so on like that. So take note of this. These are very, very important. Now let's consider law 5 once again, because of the special case we've looked at. Here's 5. It is 5, all right? We want to consider something here. Let me use this little space to illustrate what I want to, very, very important to do. It's actually a consequence of 5. All right. Now let's suppose that if n is equals to b, that means in the place of m, I'll put b. All right. So that means the law become log to the base a of b equal log to the base b of b. All right, over log to the base b of a. And from what we've considered so far over here, let's go there again. Look at this. From this, we are bold to write this result. Where is it? Sorry. All right. We're about to write this result as 1 over log to the base b of a. All right. And on multiplying out, we have log to the base a of b multiplied by log to the base b of a equals to 1. All right. And we can see this to be true from 2. From using 2. Yes, 2. Let's look at 2. Yeah, look at 2 over here. Are you seeing this? From 2 and also let's also 4. From 2 and 4, this can be written, we can write this as log to the base b of a to the power of log to the base a of b. All right. You see that? I mean, this expression, this left hand side is not this, not the right hand side, please. The left hand side can be written as this from 4 particularly. All right. Then from 2, seeing that a base a is raised to a log whose base is the base, then the answer become the antilog. So the answer become log to the base b of b. All right. And this already we've agreed that is 1. So you see that the result is correct in general. So please, these observations, put them into account. Make sure you go through the video once, twice, and thrice if possible, because we shall be using these laws to solve problems. All right. So I'll be referring to this video in subsequent videos. I'll be referring to this particular one that record from this video. Uh, we've established this, and I will give this video a special title to make reference to it. All right. So please, if you're not clear, you can reach to me. But I will advise you go once, twice, and twice so you get the full grasp of everything that is talked about. Then, as I said initially, that this platform is known for personal services. If you're interested in one-to-one tutoring, you'll be very free to reach to me. Your success is my ultimate goal. I'm one that is driven with great passion for mathematics. All right, I love mathematics from the very onset. I've been doing it for a very long time, and I studied mathematics. I went to school. What I studied is mathematics. All right, so it's very important course. Very very important. Have great application in life. When it comes to data, it has great application. When it comes to the physical aspect, like physics, engineering, mathematics, you cannot do without mathematics. All right, it's very very useful. So if you're interested in a one-to-one class, you are very free to reach to me via the email I will provide, and or you visit me through my Telegram. So thank you very much for paying attention. I really appreciate your presence. Till other time.